Silence is fine too. Hey, how's it going? My name is Obi-Wan Pez. This is N Simplex Pachinko. We'll get Pretzel going here in a minute. For some weird reason, it looked like I had canceled or like quit out of all of my Firefox windows, but they were all there, so I had to just close and reset all of them. See how it goes. No idea. At any rate, tonight we are going to be doing some mathy type stuff. So if you have any questions yourself, feel free to ask. And we'll set up a queue if there are enough. I am rather curious where everyone is. It is election night in the States. We are not doing political endorsements or gloating or anything else. So, cool. This weekend was rather big for the Elite Dangerous community. We got a new ship out, we got a new update out on Thursday, and a whole bunch of other cool things started happening. So, we're going to see if later on people are interested, probably not today, people are interested in doing some power play type stuff, which is the new like territorial expanse system that they've got going. We had been doing all sorts of power play with just a couple of weird. Had been doing a power play with just a couple of outcomes, but the problem was that we were always looking to like what is going on over here? Or in my brain. Either way. Pretzel just appears to be down, so cool. Yeah, so we have been doing power play before, but mostly the idea was you were picking one person to work for, and then once you got the special cool weapon or shield or whatever from them, you would need to defect to go to a different power and work on that. And like that's not really what they had in mind when working on this stuff. They'd wanted it to be more like an actual, power struggle between these groups. Maybe people would more align toward one person or another. So, in playing with the Boot Brigade, we decided to go all in with Lee Yong-ri, who is a tech finance genius, who's mostly working out of the Galactic South region. At least south of Seoul. So we'll see how that affects everything. And I need to redo my window. All right, there we go. Yeah, Pretzel is just not cooperating, so we will abandon it for tonight, I suppose. Alright, I'm going to pull up Introduction to Partial Differential Equations with Applications by E.C. Zakmanoglu and Dale W. Thole. So we'll see how that goes. Oh, now you're going to work. Okay. No Copyright Sounds is going to be the label that we're playing off of tonight. There are only 75 minutes worth of tracks. I suspect it's going to either randomize back into the same stuff, or it's going to complete the list and then start over. I don't know which, but... we'll see how things go. Alright, so right now we've got kind of the introductory chapter 2 is talking about different functions that are being used, and we're saying that if we have a function f of x, y, z is equal to, oops, nope, not that, is equal to z squared minus x squared minus y squared. Can't hear myself think. Shouldn't have changed anything for you. Alright, so we're going to let capital F, which is a function of x, y, and z, be equal to z squared minus x squared minus y squared. So A is find grad f, which is the gradient, which we actually talked about in a previous previous night. So we were talking about using this is it del operator, I think? So the idea here was that we were going to be taking the partial derivative of the x vector of the y vector and the z of the z vector separately, and then they're all going to become three things. This is, nope, not ordinary. This is going to be a partial with respect to x, comma, and here we have a vector, partial with respect to y of our f, comma, partial with respect to z of our f. Alright, now this is actually telling us the direction of steepest descent. This has all sorts of uses, not just in regular math, but like machine learning. We talked a bunch about in our neural networks class. We talked a bunch about trying to find gradient descent and try to get a particular neural network system to move around a little bit and change its weights based on a gradient descent. So it would attempt to find the quickest way to get to a minimum value of our error function. Well, that seems like Pretzel just kicked out again. God. Cool. I have some of the most interesting problems with this stuff. Okay. Now, in theory, that should work. Okay. So problem 2.1, find the gradient of f, and then what is the largest set in which the grad f does not vanish? That's a 1, really. A 2 is going to be, find the largest set for which the grad f exists. And Yini, good evening and welcome. My name is Obi-Wan Pez. This is N-Simplex Pachinko. Sorry about staring off into space for a little while there. I was trying to figure out something on the side, but sure, go for it. Not strictly math related, but more of a concept trying to understand. I will do my absolute best. We'll see how things go. As long as you are satisfied with a potential non-answer or something. Hey, Megamorph. Yeah, you'd like to think that. They could just recall our family at any point they wish. We could refuse, but I think that would involve her not having a job anymore. That would be pretty bad. MLEs, okay. Learn the classic way. Density function converted into a likelihood and a log. Add the log. Yeah. That's fine. Come on. There we go. Yeah, statistics was probably my weakest subject out of all the math ones. To which many people would probably be like, no, really? Yeah. Okay. Okay, so estimate the mean mu. Maximize likelihood. So you want the take the argument maximum of the probability of wherever mu is, or like that mu is in that particular location. You're taking the probability of all of your x's, which is your Gaussian distributed data points, given that you know where mu is. should be equal to argmax log of those probabilities. Okay, so we know that second to last to the last step is easy for me to see anyway. Right, they've got a log on the outside of a product, so therefore we use the log rules. That's going to become a sum. And then, since it's inside of a log, the multiplier on the outside of the E can go up. But it doesn't. Okay. Okay. No, fair. Yeah. So, I mean, it looks right to me, but again, I know a decent amount of algebra, but doesn't mean that I get every step that's here. Hey, Les. I just started doing gradient. Was looking at introduction to partial differential equations since nobody else was here. But hey, you all are here now, so. Dependence on the variance isn't explicitly mentioned, but I imagine that it ends up being a constant factor. Okay. You're starting to see your course materials everywhere. Laz, which one's that? Is that the Calc 3 multivariate? Yeah, and you need that. Honestly, that's one of the best ways to do stuff. If you're able to get your hands on some data, or make your own data, and then see if you can come up with the same result. That is proof class. Yeah. Yep, no problem. And I know Penn Center's probably decent at stats, but I don't know who else might be. Nobody signed up to teach one, so So Megalomorph, yeah, I think it's just the fact that there's like these Argmaxes that are just kind of tossed around everywhere. I'm not even that familiar with that term. I mean, I get it, but like, I don't know that we've ever used it in my classes. What input maximizes the output? Okay. Oh. Okay, so you're looking for the X value. You're essentially solving it for that maximum. Alright. I mean, Laz, if you want to see proofs, we could go back over to, where's that one? Doing mathematics. Yeah, right. Alright. So, what we want to do, gradient of this particular term, right, gradient f is going to be equal to, we take the partial with respect to x, we get a negative 2x. We take the partial with respect to y, we get a negative 2y. Take the partial with respect to z, we get 2z. Woo! Okay, find the largest set for which f exists. That's not exactly what they said. What is the largest set in which grad f does not vanish? Good luck, Megamorph! Woo! Alright. Not entirely sure that I even understand this necessarily. Because, like, for this to vanish, I would imagine it either doesn't exist or it's equal to 0. But, like, grad f would then need to be 0, 0, 0. And in which case, there's only one place that's going to do that, which is at 0, 0, 0. Yeah. It's convenient to visualize grad f as a field of vectors with one vector, grad f of xyz, emanating from each point xyz in omega, being the space in which we're working. So in this case, a 3 space. The vector space in which we're working. Alright, partial derivatives of f do not vanish simultaneously at any point of omega. So, yeah, seems it. We must make the assumption grad f is not equal to 0, 0, 0. Yep. Alright, so for this particular one, it looks like this is all real numbers, or all real yep. So omega, it's not really, is going to be equivalent, equal to R3 without 0, 0, 0. Oh, gotta get rid of that. I think. So that's our vector space is going to be, yeah. Okay. Alright, 2-1B. Sketch the level circuit surfaces. F of x, y, z is equal to c, with c equals any of the following: -1, 0, 1. Okay. Let us consider now a particular level surface given by the equation. Okay, fair enough. So in this particular case, we'll do the 0 case first. So f of x, y, z is equal to z squared minus x squared minus y squared equals 0. Now, we should easily enough be able to do this in MATLAB or one of the other 3D modeling, graphing type programs. I'm getting the vibe that this is going to be a hyperboloid. So, good times. Oy. Under assumptions on F, there is a tangent plane to the surface at each of its individual points. At the point of tangency, the value of grad F is a normal vector to the tangent plane. It's not really a direction that's steepest descent. I think I'm looking at two different things. Value of grad f is the values of the partial derivatives of f at that point. Direction of the vector normal to a level surface. At some XYZ. No, we don't want that. That's an equation of the tangent plane. I don't really need that. Sketch the surface levels. Ugh. Right, so this is also saying if you are to make r squared be equal to x squared plus y squared, so you start by making it essentially introducing an equation of a circle, then we end up with f is also equal to z squared minus r squared. Okay, so field takes on this quality. We're now c squared is equal to r squared. Okay. So if we go from 0, if z goes up to way off, but whatever. It's fine. just a cone. I think it's probably just a cone. Alright, because the sides here are yeah, sides are going to be linear because the radius r is going to be the same as the z, which is going to be the height for all values. So therefore, yeah, these are going to be cones, not hyperboloids or anything like that. Inverted, I suppose, but nonetheless. Does this mean we get negatives as well? I think so. Okay, if f is equal to z squared minus r squared equals 1. We get z squared minus 1 is equal to r squared. Might be slightly easier to look at it this way. Not really sure, but whatever, it's fine. So at this point, right? If we do this. And if we say that we've got our z squared and then we subtract 1. So at a height of 1, right, z equals 1, we end up getting 0, which is going to be our r squared value. So we end up just getting a point at 0, 0, 0, 1. Okay. 0, 0, 2. We get 2 squared minus 1 is 3, and so our r squared is going to be 3. R is going to be the root of 3. It's about 1.86. So, same thing here. I get the feeling it's still conical. Until -1, where it becomes a point again, right? Because -1 squared for z is going to be 1 minus 1 is 0. R is equal to 0. Alright, so we get the same thing going on down here as we do up here. So this separates it out into two different cones with a gap in between them. So in theory, if we were to say C is -1, then this should join the two pieces together, merge them. Is -1. Oh, no, that's not F anymore. Right, once we move stuff around, this becomes its own thing. So Z squared plus 1 is equal to R squared. So Z is 0 gets us an R of 1. So we get something that looks like that. Then at Z is 1 or -1, because either way we get a value of 2, which is going to get us a R of 1.4. Like that. But then also at this -1, it's going to have the same extra values. Make this bigger. Much more literally hourglass shaped here. Or like one of those little drinks mixers that have the like one shot on one side, 2 shots on the other. Alright, find a vector normal to the surface. That stuff equals 0 at specific points. z equals 0, r is equal to 1. And for C, the question was, find a vector normal to the surface. At 101. And find the equation of the tangent plane. I don't think I can do this in 3 minutes, but we'll see how it goes. Ads are coming up, so thank you very much for sticking around. Find a vector normal to this, so we already got the grad f was equal to negative 2x, negative 2y, 2z vector. Taking out 101. It's going to get us a negative 2, 0, 2. Okay, so this is going to be equation of the plane. There is a point slope version of this which works out pretty nicely. So we get x minus x0 times the normal at x specifically. I think this is it. Yep. Plus y minus y0 normal at y 0 plus z minus z0 times n at z is equal to 0. Yep. So according to all that stuff up there, right? X, this is x minus x0 is 1 times negative 2, which was our n at x right here. It's our normal vector. Normal at x, normal at y, normal at z. Okay, plus normal at y is 0, so we skip. And then that's a 2 times z minus z0 was also 1. It's equal to 0. So that's the equation of our plane. Alright, we'll be back in 3 minutes, taking a quick ad break. Thank you very much for sticking around. Here we go.
We have our backs whenever our foes come by. This time we will win. This time we'll have to join forces. This time we will win. This time we'll have to join forces. to join forces.
Tonight is hashtag not sponsored by Northern Monk Chocolate Fudge Brownie Dessert Stout. Yeah, that does actually taste very sweet. So if anybody is interested in like sweet beer, dessert beer, this is it is quite on the chocolate side. Oh, and unlike the United States, they very sensibly have put actual ingredients on here. Okay. Water, malted barley, oats, wheat, lactose, hops, natural flavor, vanilla, and yeast. So, yeah, the vanilla and natural flavors really do explain the why it smells like chocolate. So that's a pint of the dark stuff. And it doesn't have any like actual sugar, like lactose a little bit, but and then as we try to do we will also redeem a good form. Yeah. Forgive the mess. Yeah, it's pretty much the same. Alright, well, let's see. Can't get really out of frame there. Alright. Is this good? Yep. Alright, it'll have to be. Alright, so, I am, well, in the United States. I was a student of Tangsudo Karate, and as such, being first degree brown belt, I was probably a year or two away from really getting serious and starting in on black belt. And then we moved, and there is no Tangsudo immediately around us. We got a few different options up in Yorkshire, but so I decided to go with Eskrima instead. That's my stick fighting art, which I do occasionally. Or I did last time, so if you're interested in seeing that, a little bit of the like Eskrima workout, you could see a number of my other streams, which will have that in it instead of Tangsudo. So I'm going to do my 2 black belt forms, Shinte and then Basaidai. Alright, Shinte. Oh man. Is it that way? No. Uh-oh. We come. Oh, that's right. It's this one. Alright, now we gotta shift, because otherwise I'm gonna hit something. From here, it is a block punch, a block at elbow. And then we come back around. Down block. And then we switch to a defensive pseudo, which is in a Fugal stance. So it's a defensive stance. And then we switch sides. And then we switch to the offensive Chonggul stance. Okay, then this one's the front kick. Grab. Spin around, tossed. Spin them this way. And now we gotta go back here, otherwise you can't see anything. Do 1, 2. Spin. 1, 2. And then we have to, again, shift. Normally you wouldn't do this much shifting. So here, this is a like cross block to the leg, essentially. And then we rise up, and you're doing 2 ridge hands to the necks of people who are coming at you, allegedly. And then we do a God, what is this called? Anyway, we're gonna turn, bring it back down, and then lock and load and pop back up. And then we do our up block punch, up block, and elbow, and then back. Tension. And then we're out. So, forms are typically a choreographed series of movements in order to sort of like highlight your various skills and your control level. A lot of people are like, well, this is stupid, like nobody would actually attack like that. No, that's fair. But it's not about that. It's about all the different combinations that you could make and trying to make sure that you show control for all of those things. Okay. And then we do... Dito draw. There we go. That was that. So when you're here, you step back and you're reversing the stance from this side to this side. It also switches which leg is in front. Or no, it switches which leg is in front, but it also switches the direction. What do I want to say here? Right, so if I'm in a triangle stance and I'm facing this way, and then I just pivot where I am, like I'm now diagonal to the wall. So that 135 degree turn is not entirely useful. We want to make sure that we have 180 degree turns. So in order to do that, I need to make sure that my right leg is going to be on the right side of my body when I'm facing the other way. So this is why we bring it back behind us, and then when we spin, now it's on my right hand side and I'm now facing exactly 180 degrees away. So if I'm here, bringing it across and then turn. Okay, side eye. Which side is it? I think it's here. Yeah, it's that side. Alright, so we do a chop, punch, back fist, and we're kind of leaning way down. Chop, punch, back fist. Then we go up to a pseudo, 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 immediately go back, block, basically doing a brush parry. So something's coming at you, hand, foot, whatever, brush it out of the way, bring it back up to your forehead, do a side kick, drop into a pseudo going the other way, pseudo, and then from here, something's coming at you, so you up block, go again, pop down, and you're hitting their ribs, and then punching in the solar plexus. And then we do a pierce back behind again, and then draw out. So this could be thought of as a number of different things. The pierce is typically a groin strike, and then you're getting a nice handful of anything that's there and pulling up and back. If it is jeans material, that will definitely cause the person to get off balance quite a bit. So they can go flying if you do it right. Okay, so then we go up, Kima stance, down block, and then I think that's it. Yeah, here, ridge hand back out, and this is usually where you actually yell and do a kyo, but I'm not going to do that because my kids are asleep. My wife just went upstairs, so, you know, be nice. You do a crescent kick, and then a head smash, and then punching kyo. And then from there, come back up, draw over. Nope, it's here. And this is going to be a double punch. come back, whip to the other side, crescent kick, double punch, whip, crescent kick, double punch, and then from here, have to shift, we go step back, so we're bringing our fists up, and then letting them fall like a hammer, and just whip down with the knuckles. And then we go to a pseudo, and then you have to do a jump change to end up on the other side. These are not black belt forms for nothing. There's a huge amount of control that goes into it. I've been doing Tang Soo Do for almost 20 years now. When we go back to Maryland, I think I'm gonna actually settle in and get my black belt, but I'm gonna have to work super hard on the fighting part of it. Like I do a pretty good job with the forms. I do a pretty good job with jiu-jitsu part. So if somebody is coming at you, somebody comes at you and then you simulate like what kind of grabs you're going to do to put the person on the ground and then knock them out, or worse. So I hope y'all are having a lovely evening. All right. So. Okay. What's the equation of the tangent plane to the surface at that particular point? We already got that. That's that one here. What happens as at the point 0, 0, 0 of the surface? There is no gradient. I mean, it's not even, there's no normal curve or whatever, no normal vector, there's no surface. It's just a point. So because it's just a single point at the center, can't do anything. Sketch a surface described by the equation z minus c0 squared minus x x0 squared minus y minus y0 squared equals 0. For some fixed x0, y0, c0. again, this is like 1, and then 2. Show if n is equal to nx, n, y, n, z. Is a normal vector. Then nz squared minus nx squared minus ny squared is equal to 0. And 3, show and makes a 45-degree angle to the z-axis. All right. Supposing that this point here is x0, y0, z0. We're going to get this conical shape. Okay, so we're going to get this conical shape both above and below. It's connected at x0, y0, z0, centered around that point. Goes through that point, that's the center of the two cones, and then it goes off from there. Show that if this is a normal vector, then this is equal to 0. So must also satisfy those equations. So that means that n, the normal vector, is going to be partial f with respect to x, comma, partial f with respect to y, comma, partial f with respect to z. So therefore, right, and z should be dftz parentheses squared minus partial f with respect to x parentheses squared minus partial f with respect to y parentheses squared. Okay, we assert it's equal to 0, so then here if we take their partial derivatives with respect to the appropriate variables, we should get 2 z minus z0 minus 2 x minus x0 minus 2 y minus y0 is equal to 0. We could potentially divide everything by 2. Z minus z0 minus x plus x0 minus y plus y0 is equal to 0. Andrew Holding, good evening and welcome. My name is Obi-Wan Pez, and this is N-Simplex Pachinko. And yeah, let me know whereabouts you stopped and or feel comfortable, and then we can maybe go from there if you have any particular questions. This is Calc 3 type stuff, which is leading into partial differential equations, which I'm trying to sort of reteach myself a little bit. Never stopped, yeah. Genomics and network reconstruction. Well, alrighty then. That's pretty awesome. So I teach, I taught at community college for about 15 years in the States, and then my family decided to move out to the UK, and we're spending about 3 years here, and then heading home, you know, slightly after the midterm election. In the UK, nice. York, alrighty. Yorkshire, woo! Yeah, one of our TAs who is often, I don't really do TA all that much in this stream, but one of our other guys has a TA who that's not what I wanted. Is living in the Thirsk area, and he helps out on Dr. Gold's stream. Oh goodness, that might be wrong entirely. Uh-oh. He's gonna laugh at me. Nope. Fail. Completely and utterly. Well, I'll find it eventually. Oh, you know what? That's probably it. Okay, seriously. Oh. There we go. Okay. Forgot there's a year in there. Hey. Yeah, you know, it's sunny and warm all the time. So it was for my spouse's job. She does programming and has a team that is in the US, and they're connected with a team here in the UK, and they were like, let's her friend was working at like sort of the same level-ish, and then started to get into management, and she moved over here to do this, and then said, you want to do this? And you know, my spouse is like, okay. And then she's like, no, you want to apply for this. So we looked up the benefits and stuff like that, and given that the employer is paying for the kid's school, is paying for all of our living reasonably all of our living expenses, and also paying her the same salary that she was earning in the United States, we're basically like at the same level with me not working. And if I do find some sort of footing on Twitch or YouTube, or force myself to go out there and get an actual job, then like all of that money is essentially just going straight to the bank. So we'll see how it goes. Yeah, so we kind of lined it up so that like we could have gone to the local grammar school, but the problem is that I think you're probably aware, the waiting list is like 2 years long, and we're only here for 3. So, so we called the local private schools and did interviews and stuff like that, to see if we were interested. So we, narrowed it down to 2, and then got selected into the appropriate one before we left. That was really cool. That both of our kids could do all of their placement assessments before we left. So that was, 6, 8, 10 months ago, something like that. Sold our house, so we no longer have to worry about that. We sold all of our both of our cars. We sold a bunch of stuff, gave a ton of stuff away, and then just like shoved everything into storage that wasn't coming with us. And first shipment, we had a weight allowance of 1,000 pounds, or something like that. I think we were at 1,250 when it came back. Like, oh. So I think that like the grammar school in this area is rather limited, but there are many more private schools, so it just happened to work out that like, all right, well, they're paying for it anyway, and this is one of the better schools in the area, so we're just like, all right, let's go for it. So we're pretty happy so far. The administration is nice. They've been doing all sorts of cool stuff, and yeah. And our daughter is learning French, Latin, German, and Spanish at some point over this year. And oh yeah, no, I get that. It's just we were somewhere in between the pretty much that previous statement that you had, where like the employer's paying for it, so like whatever, it's fine. And the fact that like our kids' classes are all less than 20 students, I think, with very few exceptions. Naturally, they'll have more kids in like, well, I mean like gym class, right? They'll toss a bunch of they'll toss like the entire form together, just so that they have enough people to field 2 full teams with reserves. But yeah, it's been interesting, like I said, for the last 6 months, and we'll see how the rest of the year goes. We already took our half-term break. We spent a week in France, and like the fact that Paris is accessible by train, basically 5 hours-ish. It's pretty nice. Yeah. Then I think we're gonna do Germany by plane in December. then my spouse is looking up, like, you know, all these other places we can go. Do we want to go to, like, Budapest? Do we want to go to Rome? Yeah. Italy is on our list. Greece is on our list. Budapest is on our list. Friends of ours just got back from Budapest, and they were like, you know, it was really great, except the fact that, like, you know, I don't speak Hungarian, and they know it, and they're not super happy about it. Like, yeah, I'm spending tourist money, but at the same time, it's like, I'm just coming in and speaking English, and they're like, hey, Sensation. I was saying you were TAing over on Dr. Gold's channel. And you were also in the greater Yorkshire area. Yeah. There's also a guy. Science Streams. His name is Bilint. He comes, or his family comes from Hungary. He himself has been like, I think New Jersey born and bred or something like that. So, can't remember 100%, but like he's just always been in the United States, but his family is largely from Hungary. So. Oh dear. Don't start a fight. I will say, I finally watched the last season of Doctor Who with Jodie Whittaker, and the Yorkshire teasing between Dan, the Scouse, and Yaz from Sheffield is it's pretty great. And somebody says something to Dan about being from Liverpool, and she's like, hey, I make fun of him. You don't make fun of him. I'm like, oh, that's proper siblings right there. Because, you know, if somebody came up from London and started making fun of one of you, the other would be perfectly happy to be like, no. All right. Yeah, it's Sensation. You also missed the 2 other shoutouts where I completely got your name wrong because I forgot the numbers at the end. So I finally went over to Discord and went, oh, yep, there we go. I will say, if you've never been to York, Maine, it's a very different vibe. Alright. If that is a normal vector, then that must also satisfy the equation. Oh, that's pretty cool. I'm assuming you mean University of Virginia. I was down in Maryland for better part of 20 years. Be nice. Yeah, yeah. Have you ever heard the term trailer park? Because that's the area of the country that I'm from. So that's the other thing, right? Is that like everywhere has it's not all one thing. I was told not to go to Bradford at night. I was like, "What part?" They're like, "No, just no." I'm like, okay. Alright, so I'm having some trouble seeing where this is going, just because of where we are. Oh, wait a minute. No, 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 no. No. That's the problem. It's that squared. A. There we go. Okay. That's much better now. We're gonna have to change that up a little bit, but... Okay. So that now is the same as the original f of x, y, z, which is equal to 0. Alright, show that n makes a 45-degree angle to the x-axis. So, we want to say that... n dot 0, 0, 1 vector. It's going to be equal to, so dot product is each individual thing multiplied matrix style. But instead of, no, we are adding. Anyway, we just end up with z portion. So this is going to be partial f with respect to z times 1 plus a bunch of zeros. That's not it. Hang on. It's been way too long. Normal A times normal B times the cosine between. No, that's something else. That's cross product. Ugh. It's been way too long since I've done any of this stuff, so just like you, Andrew, right? It's gonna cross product 377. I think maybe tomorrow I gotta go for a bike ride. Yeah, normal A, normal B, sine between. Sine between. Hey Phobos, how's it going? Alright, normal N. Normal 0, 0, 1 times the sine of theta between them. Oh my god. And I need to start putting my books away because I've got so many just in a huge pile over here. Nice, nice. Yep, had a bit of a slow start to the stream, but people started coming in and have more and more conversations. Great. Things are going pretty well. About ready to start that second ad. Curses. Okay, so normal is going to be the square root of df dx squared plus df dy squared plus df dz squared, all partials, multiplied by the square root of 0 plus 1 squared, which is just going to be 1 times the sine of theta. Okay, so that's going to be the square root of that's a negative 2x parentheses squared plus negative 2y parentheses squared plus 2z squared times 1 times the sine of theta. I don't know that this is actually going to be helpful at all because I don't have any information, I think, on what the cross product actually is going to be. So it's not like we have another side that we can just... I don't think. To the z-axis also implies that that's going to be off of... no. because that can be from any point on this surface. Blarg. The identity from part 1. Yeah, I mean, eventually. Oh, I see. Right, that's this stuff here, isn't it? Well, no, that's difference between, crap. Alright, I think ads are starting to run, so. Sorry, we'll be back in 3 minutes here. Sorry. Alright, welcome back. If anybody has not followed Phobos Dream, please do so. She's doing all sorts of stuff, mostly including math and software development. So, really cool stuff. And one of our many EduTwitch personalities who are here. We also have... I can't remember, Phobos, if you're on the second list, which I'll get here in a second. Our... We have here our list of, or two lists of math type streamers. So we have Dawn Does Math, who is also running concurrently to me. Zach at E to the 2i Pi has been doing a whole bunch of stuff. He is also finishing his dissertation at the moment, so kind of things are a little spotty, but he's around pretty often. Typically also on Saturdays, he's got like one big stream that he does for a lot of the day. Penn Center has been managing his math department in British Columbia, in Canada, and has some other fun, like, gamey type stuff that he does. Ian Stuckey is one of our friends who's doing a project called No Royal Road, which has been kind of a let's relearn geometry all over again, from a much more focused perspective. Obi, that's me, and Simplex Pachinko. Danny Highway has been on a bit of a hiatus lately, but hopefully is coming back fairly soon. And Dr. Gold at Actual Education does a lot of SAT type help, other fun stuff. He's got a 501c, I think, C3, 501c3. Stokey! Yes, there's your project. Oh, I guess it's over there. Oh, everything's going pretty well. Had a bit of a slow start, but got a whole bunch of people in, and we're talking Calc 3 type review of... Yeah, we're doing like Calc 3 review stuff for an intro to partial differential equations. So just kicking some ideas around, not really working terribly hard at it. Right? Yes, Phobos is on this one. And our second list has been started. So we have Meriwether Remark, who is learning a bunch of stuff and is an engineer and trying to do all sorts of cool things. Noble Penniless, or Brian, is... oh no, I don't remember what he does, but math stuff to help. Phobos Dream again, as I said, and Physics and Depression, who talks a bit about physics and mental health. And also does mathy type stuff. And XMD, XMDI, 0. I honestly, I have not actually been on their channel at all, so, but they're on our list, so, you know, must be pretty good. Anyway, so those are our people. Andrew, I hope you have a good one. Good luck, and have fun in London. Hope you have some fun, not just everything business. All right. Business will be fun. Okay, that's even better. Well, take care. Have a good one. Alright. So this is going to be equal to, we got square root of... You know what? Let's just take the 4 out of all of that stuff and take its square root. It's going to be 2 on the outside. Then we get the square root of... this is going to be... Okay, so actually, right, as Andrew was saying earlier, we can substitute some stuff. In this case, it's actually going to be that our x squared term and our y squared term can add together from this bit to be equal to our z squared term. So we're going to end up with 2 z minus z squared, z minus z0 squared terms. Shorten this up a little bit. Times the sine of 0. So this is going to be 2 root 2 times the absolute value of z minus z0 times sine of theta is going to be equal to, this is, that's a scalar. How is that a scalar? Oh, okay. The right. This is going to be the absolute value of, or norm, not norm, distance of. Vector made by u. The only things that are going to be relevant here are those which have a third item in our 0, 0, 1 vector of 1, right? All the rest of the ones are 0, so we can just kind of kick it off to the side. It's fine. Let's see. Position 1 is going to be A2, so that's partial f with respect to y. N, yeah. Times B3 was 1. Right, so we don't even need to write it. It's fine. Comma. Second position in the vector is going to be a negative partial f with respect to x, comma, 0. This is going to be the square root of df dy squared plus negative df dx squared which negative df dx is the same as negative df dx squared is going to be the same as df dx squared, which follows the same rules as above, i.e. that x minus x0 squared, once we factor out the constant, we're going to be left with x minus x0 squared and y minus y0 squared on the positive side of the equation is equal to z minus z0 squared on that other side of the equation. Okay, so we can combine these and eventually get that. Alright, this is going to be absolutely nuts. It's going to be great. I think I see where this is going, and I'm not sure I like it. No, wait. There's a 2 coming out. That's okay. Yeah. Okay. So this is going to be the square root of df dz squared over right? Because, yeah, dfdx squared plus dfdy squared is going to be equal to dfdz squared. Okay, that works for us. Then our 2 root 2 times z minus c0 normalized is going to be here. Not normalized. Wait. That's going to be equal to... right, it's the absolute value of dfdz. Which is going to be 2 z minus z0. Yeah? dfdz 2 times z minus z0. Yep. Okay. I'm okay with this now. Unsurprisingly, I suppose. Right, 2 root 2 absolute value z minus z0. This is now the absolute value of 2 times the absolute value of z minus z0 divided by 2 root 2 absolute value z minus z0. Those are gone. Those are gone. Which leaves us with 1 over root 2, which is equal to the sine of theta. So theta is going to be equal to 45 degrees. In theory, it could also be 135, but we were only looking for an angle that was between 0 and 90, so we're good. Woo! Okay. That works. Yeah, I mean, all it really took was remembering, quote-unquote, the formula for cross products. So how's everybody doing? What are you all been up to? Find the equation of the plane to the paraboloid. X squared plus y squared. Bit of a day. Oh, sorry. At point 1, 1, 2. Oh. Election-wise, or... Sorry, I filled out my ballot like a week ago, so... But it also needed to be back in Maryland for tonight, so... or needed to be postmarked by tonight, so I had to make sure it was at least in... Yeah, there we go. I voted. scrounge together a bit of geometry. Going to a really nice seminar. Ooh. You know, that's probably the one thing that I could really do with right now is going to a good conference. But, and getting some resources together for a workshop this weekend. Nice. Yeah. Joint math meeting. I mean, really any professional org would do. Of course, I would prefer a Matic, but you know that's just because it's a community college oriented conference. Next week? I don't remember. It's coming up soon though. Yeah, 14 to 17 in Atlanta, Georgia. Hey, Megalomorph. Yeah, I was just thinking, like, it has to be somewhat recent. Or somewhat soon. Because the one I did in 2023 ended up being 23? No, it was 22. Ended up being the week before Thanksgiving, and that was like slightly early-ish, I think. It's something like that. I don't remember. Whatever. It was in Toronto. I liked it. That's right. They did like St. Louis this last time around. I was just like, yeah, have fun. No offense to St. Louis, but it was not a destination conference. Hope I'm not frustrating you too bad. Right? So yeah, bring everything over like we did before. Minus 0 minus x minus x0 squared minus y0 y is equal to 0. Well, okay, so yeah, that one doesn't. Okay. Fine. Normal x plus normal y times y minus y0 plus normal z minus z0 0. Yeah, I mean, that's fair, right? Like, it is certainly a mathematical arch and would be awesome, and we could do all sorts of cool stuff. But at the same time, it was kind of like, wait, was it? It might have not even been. Hang on. (2023) math's a hit. Omaha. Yep. It was Omaha, Nebraska. I'm not gonna like bash Omaha, but again, not exactly a destination conference. Yep. The one in Atlanta, the reason I wanted to go to this one is that this is 50. This is the 50th. So it'd be like really cool to go to the 50th anniversary of the original Amatic meetings, but well. I should probably also figure out if I'm still paying dues to this organization. Like, no offense, but I'm not living in the United States at the moment. My profile. We've had trouble sending to the address you provided. There's a reason for that. Really? Oh, really, guys? Come on. That is frustrating. Okay. So I just looked up. I can enter that my organization is independent, which is true because I don't belong to an organization anymore. I can enter my city or town as APO because I now get mail at an APO box in the United States. State. When you do this, you say that you're part of the armed forces, and then like whatever thing you've got. So in this case, my options are Armed Forces Americas, and Armed Forces Pacific. We're missing one. So I'm gonna have to update my home address. Whoa. Alright, good news. There's a lot of stuff. Ooh, I didn't notice that before. You can submit an article off their website, so that's good. Okay, now I do have a problem, and that is that I cannot, oh, there we go, edit personal information. No. Oh, this is not good. So interestingly, on their website, I can enter what my preferred mailing address is. There is a pull-down menu which says blank, employer, or home. I don't have an employer, so fine. So I hit home. That's probably going to my old house. Okay, from the top. Personalized URL, username and password, email address, manage email preferences. Personal information, full name, suffix, screen name. Okay. Professional information, organization, city, town, country, state. Additional information, preferred mailing address, home or work. Okay, but there's... I can't change my home address, apparently. Alright, maybe we need to go to membership services. No. Doesn't look like it. Oh, man. Crazy. Okay, contact Amatic office at the following email address, so I might just have to do that. Oh, they upped the price, man. Okay. This is not helping. I need to update my home address, like... Annual conference, webinars, training workshops, professional publications, Mathlete, grants, membership type. Nope. This website is not entirely helpful. It's really too bad. All right, let's. That's gonna be frustrating. Okay. Never mind. All right, get rid of that. Good times. So yeah, we are here. We need to find the normal vector associated with all this stuff. So, normal vector is going to be equal to the right, so this is going to be -2x comma -2y comma 1. So, and x is going to be -2 times the x value is 1, so that's going to be -2 by x minus x0 is 1 plus, and y is going to be -2y, which is also 1, so -2 times y minus 1 plus n sub z is 1 times z minus z0 is 2. So 0. Okay. Equation of the plane. Find the equation of the plane tangent to the paraboloid at the point. Yep. That's it. Alright, 2, 4. In our square level surface of a function f of two variables is a curve, level curve of f, and a tangent plane is a line. Yep. Find the equation of the line tangent to the curve. X to the fourth plus x squared y squared plus y to the fourth is equal to 21. True 4? Yeah. I mean, same stuff that we did, right? This is just going to be grad f. So we're still doing this on at 1, 2. So same deal here. Grad f is going to be equal to 4x to the third plus 2x y squared plus 2x squared y plus 4y to the third is equal to 0. We don't necessarily want it to be equal to 0. No, that's just taking the gradient of both sides.
Open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight.
Okay, so anyway, we just want the equation of the line. So 1 minus y0 is equal to m times x minus x0. M is the first derivative at x0, y0. Negative parentheses 4x cubed plus 2xy squared divided by 2x squared y plus 4y cubed. Alright, and so dy dx at 1, 2 is going to be equal to negative parentheses. This is going to be 4 plus 2 times 1 times 2 squared is 4 over 2 times 1 squared times 2 plus 4 y cubed is 2 cubed is 8. Alright, 4 plus 8 is going to be 12 divided by 4 plus 32 is 36 is negative 1/3. Cool. Y minus 2 is equal to negative 1/3 times x minus 1. Y equals negative 1/3 x plus 1/3 plus 2. So 7/3. Okay. That's it. Cool. Anybody got any questions? Alright, with that, I think we might switch over to a game. Woo! We did get, for free I might add, the new update to Slay the Princess. We also got, I mean, we still have the Against the Storm, which we're working on. We've got the Ever Something to Do Elite Dangerous. We got Satisfactory, we're still running. Can't say I know exactly what I'm doing with Satisfactory at the moment, but and I'm gonna need to figure out what's wrong with my Linux box, because there's something going on with Epic, and like I can't get any of that stuff, which would have been really nice because we have a lot of like spooky type games that we could have run through during Halloween, but it's just not working. Could you convince me to chat about a combinatorial game? Alright, I'm going to start a poll. 4 options, and then we'll go just cuz. And I will take a quick break on running ads a little bit early, just so that we include this as well. Democracy never works, right? We'll see how it goes. Yeah, so we can try out the chat about a combinatorial game. Did you want that to be like tomorrow? It's part of stream right now. What are you thinking? You're thinking at the moment. Okay. Um, tell you what, yeah. I'm gonna drop this stuff downstairs. Let that let the ads run and the poll run, and then I'll get you on Discord and we can chat live if you're interested. So we'll see how things go. I can't promise anything, of course, but you know, if you just want a perspective. All right. Alrighty, sounds good. Be right back. Check out the poll, see if anybody is interested in stuff, and we'll be back. I've said it before, and I've said it again. I'll say it again. Democracy doesn't work. Nah, that's fine. All right, here we go. All right, so how do we do this? Elements west. Hello.
Oh, okay, I think I'm here.
Yep.
Hello.
How's it going?
Yeah. I am now hearing myself twice. I'm doing well. How's it going?
Yes, I hate that too.
Oh goodness. Yeah. So I was mentioning this workshop, and sort of the brief story is that there's I'm going to be introducing some games on graphs to people who have never seen graphs before. And these are games that I'm not super familiar with either. I came
Okay.
across them some process.
I do like games.
Yeah. I mean, they're combinatorial games. So it's like, can
Yeah,
debate. Uh, but yeah, so for me, the task the sort of the meta task that I have is I want to give them examples to play around with, and I need to come up with sort of a reasonably small set of reasonably interesting graphs to play this game on. So I'm tapping on shoulders to see if anyone can help me.
Sounds interesting. Do you have
Oh,
a specific set in mind?
oh, that is not the link that I meant to post, but it is relevant actually. It's no, I don't. Right now, I'm still fully in the there was some discussion in that proposal that I just sent about trees as like a place for analysis, but I think that's sort of all the guidance that I have. Grass is small diameter. Um,
Over there. Okay.
Yeah, so this is called the interval game. And let me just describe it for trees first, maybe. The path. I don't know. What's your favorite hydrocarbon? Right? Like,
My favorite hydrocarbon?
yeah.
I think benzene, so we're probably failing.
Okay, so we take turns with doing the following. So we pick a color. I'm gonna do orange because it's high contrast. I pick any two vertices that are not already orange. So I'll pick these two.
Mhm.
I look at the shortest path between these two vertices,
Yep.
and I color all of those vertices orange as well. The last person to take a vertex wins. The person who gets the last.
Okay, so game and nim.
Well, I mean, yeah, it is. Somehow it is a game of nim, although I have no idea how that reduction works.
I mean, it's a variation, but
Yeah. Is there a case when it literally is nim? Ooh, I don't know. There's a case when it's like a sort of reasonable variation of nim.
so
Which
well,
is-
there are certain variations which are like you're allowed to take, are the stick one, right? If you could take 1, 2, or 3 of the pickup sticks that are on the ground, and then
Right.
last one to take a stick wins, or last one to take a stick loses. So
Either way.
it's effectively going to be the same thing here, where you're like, okay, how can I choose such that my opponent will not be able to put me in a bad position. So if I'm going as second player, right, I'm assuming I'm just going to pick blue here. And like I would pick this vertex and Not that one, because I want
Not that
this
one.
to be
Yeah.
something slightly different. What do I want? If I pick this one, it's got 2 endpoints left. So I want three. I want 3 endpoints left.
3 endpoints left, yeah.
So as long as I can make it such that there are an odd number of endpoints remaining, then I will continually win.
Yeah, not 1, but other odd numbers should be good.
Oh.
Um,
No, that's a good point, because...
Right, because so I could, for my move, I could pick the 2 vertices, these 2 vertices, right? And so that
Can you?
I am allowed to do it. Yeah, that,
Oh, okay.
that gets rid of the degenerate case where there's only 1 uncolored vertex. You still win, of course.
Right. So whether you pick 1 point or 2 points, I'm going to be able to do the opposite.
Right.
So yeah, I think as long as you try to maintain an odd number of endpoints unselected, then you're alright.
Interesting. Okay. Let's try that. So if I were to try then something like small variant on my move, I'll do this.
Uh-huh. So you've got 1, 2, 3, 4, 5, 6. 6 total points, and 1, 2, 3, 4, 5 overall.
Right.
So I think if I select here and here, that's again going to lock you.
I see. Okay.
Whereas if I picked, for instance, if I just went from here to here, right, this now
Right.
allows 4 endpoints. And then you could win by working with that.
Good. Yeah, I could do this.
Right. Yep. That locks me into 3.
I see. Oh, so I misunderstood. Wait, but hold on.
Okay. Sorry. Let's go back.
No, no problem, no problem. So here in the top one, I left you with 4 endpoints after my first move.
May not
And you-
entirely as easy as I think it is.
Right, yeah. And here, yeah, you would leave me. Well, the 4 endpoint move was bad for both of us. But
Right.
my 5 endpoint move was also bad.
So I guess everybody's racing to 3 is really the key.
I see, because right, we can sort of get there. So maybe this is one of these Nim-like things where 6 endpoints would also be good. With the intuition being that if you do 2, then I do 1. If you do 1, then I do 2, right?
Yeah.
That actually plays out.
So you could generalize that and manipulate it such that you always have a multiple of 3 that you're passing.
Right.
And that way it will eventually lock your opponent in.
Right. we try this principle, then the claim is that this graph, which sort of our first guess is that this graph is a second player.
Alright, so there are currently 6 true endpoints. I'm gonna not worry about the middle ones on any branch. And we'll use those merely as extra
I guess.
endpoints if we need to.
Right, yeah, let me just throw on some. Just in case, just in case.
Yeah, no, having fewer might actually confound it, so that might be a good
Okay.
idea. Because if both players know this, right, then it could be exploited and could fail potentially.
Right. So I don't want you to get to 3, but the claim is that I can't stop you from doing that.
I have effectively passed you 6 by just starting on a board
Right.
with 6 endpoints. Yeah. If
So
you're a first
I'm
player.
going to pass the buck, and I'm going to say, now you have 6.
Mhm.
I guess I should. Or, well, I guess that doesn't matter because you can still pass me 6 if you want.
Uh-huh. So if I am a complete jerk and say I'm also passing you 6,
Right. Then this plays out like we think. I'll try that.
so you get rid of 1, and then I'm gonna take 2. So I
Yeah,
pass you
and
3.
boxed me in.
Yeah.
Interesting. Okay. Yeah, so there's still plenty of play when to try to figure out how to get the passing to happen in your favor, but this
Right.
endpoint thing is important. That's a good insight.
Right, because the internal ones you could have a whole bunch.
Right.
And then you could also manipulate it such that you're using an internal one to pass on only one fewer endpoint.
Right.
And then also you could be using an internal point. Oh man. I think that gets much harder very quickly. Because it's just going to depend too much on what's available. So that might actually be a good thing in terms of like not making it super easy.
For sure, yeah. Okay.
I'm interested to know if your group finds any sort of specific strategies.
Yeah. I mean, me too. Yeah, this goes down. But yeah, I think the only thing that's been written down is that it's known that caterpillars are a first player win. So that's if there's a path with potentially some single edges sticking out of it. And maybe the caterpillar has to be, a reasonable size. There's these small games always run into issues, but
Yep.
but yeah, it's still fairly unexplored, at least in the literature. Um, but it was proposed for this workshop a couple of years ago. As you see from the link that I accidentally sent. But
That's good.
yeah. Well, I'm happy to call it here unless you want to keep playing around with it. But I don't want to keep you too long from the game.
I mean, it's not a big deal. Yeah, I don't know that there's going to be an efficient internal strategy. I think it's going to depend too much on what's there. I know I said that earlier, but I don't know.
I think that another thing that I'm gonna sort of take to the group is the this question about how like these trees, the sort of pretentious name which now people know about is homeomorphically irreducible, right? Because this was the problem from Good Will Hunting, right?
Yep.
But if you have these extra internal things of degree 2, then how might that affect the? It's a reasonable question.
Yeah. Like, how can we make that all work in our favor? Force our opponent to have to do something. I was playing chess with my daughter the other day, and she ended up moving. She did something in the first game that we played and that actually like started confounding my strategy. I'm like, huh, all right, you're doing all right. And then second game we made like a, I don't know, 5 or 6 move mate that it was so quick. But I did like 4 or 5 moves to get into place and put her in check, and then she moved her queen just out of the way, and then like I took another move or 2 to take the queen out, and then the next move was to get back into the exact same position that we were before, but this time the queen was gone, and it caused the king to be a mate, and I just put my piece down and I was like, oh wait. Huh. We both look at it. No, I guess that's mate. Alright, cool.
Reset.
Yep, I was playing Life with my son at the same time, so that was also led to distraction.
Oh, that sounds like a delightful evening.
Well, they were both like, we want to play board games, and they were like, I want to play Life. I don't. Like, okay. Play chess with both of them. Play both sides. Oh, Phobos, do you know the Darren Brown method?
I don't.
Or Stookie. Yeah. Sorry, you have not.
No.
Yeah. So he played 9 Grandmasters at the exact same time. And Darren Brown is known for his mind games. I don't know if you've seen any of his stuff on YouTube or wherever.
Okay.
Yeah, so he wrote a book called Mind Games, I think. It's probably upstairs now that I'm trying to look for it. Yeah, it totally is. Or Tricks of the Mind. Anyway. So yeah, he was doing a thing for his TV show where he played 9 Grandmasters in the round. They were all facing out from him. And the thing to notice was that every other board he was playing the other color. So it goes all the way around the whole, the whole
wait.
thing.
Okay.
And he said he caused either checkmate or resignation on 8 of them. And they were just like, I don't know how he does it. He just must be brilliant or something like that. And he says, okay, so here's how I did it. The only game that I actually played was the first one. Or the only move I think he made was the first one, which he said was, the most common move that almost everybody does anyway, move a pawn to the center of the board. And then on every other game, all he did was he took the move that the Grandmaster made and did that at the next one.
Yeah.
So he was playing them against each other all the way around the whole thing. And they're all like, this guy's not ranked, like, so they're invested, and they're just like, oh, that's it. No, I'm not resigning. So they played until a very long way through the game where they're just like, all right, can't do anything. So he definitely lost the first game, and then all the rest of them he ended up, I think all the rest, he ended up, winning by resignation or winning by checkmate. But it was because the Grandmasters were playing each other's.
Oh, that's funny.
He does all sorts of weird stuff like that. One of them, he was doing mediumship. So he was on stage and pretending to be like a 19th century medium, put a blindfold on, mystique, and doing all this stuff and saying like, I think there's somebody named John up in this row that has like a certain problem that you wanted to contact me with. And sure enough, what do you know, there is. But then he'd, go through and do the kind of thing that they would have done in the 19th century when they were doing all the medium hype and all that. But I'm pretty sure that I know how he does it. That is that he has a research team find out who is coming to his show and pulls information from their social media.
Sure, yeah.
And the only real thing that he's doing is memorizing that information before the show until when he's bringing it up in the show. It's like that's the trick, and at least I think. And but I mean, it's a really good one because it's just such a massive amount of information to memorize. He can just do it. Craziness. All right. Do you have anything else you want to talk about here?
No, I'm good.
Alrighty.
Thanks for humoring me.
Yeah. Thanks for bringing it up. All right. I'll see you back in the chat. Okay. So we got 1 vote for Elite and 1 vote for Satisfactory on the poll. Alright, so since I'm being forced to pick myself, actually, oops. Huh?